EMF and potential difference. A battery is a device which maintains a potential difference across the two terminals. A battery is a device which maintains a potential difference between the two terminals A and B. A and B. This is due to internal mechanism in the battery material that exerts a force FB, battery force, and accumulates and drives the positive charges towards A, positive charges towards plate A, and negative charges towards plate B, towards plate B. The force is known as battery force. The force is known as FP. The force is known as FB. As accumulation of charges increases, as accumulation of charges increases, or is increased, the potential difference between A and B develops an electric field. E. So electric field is from positive plate to negative plate. So electric field is towards right. This field exerts a force F E is equal to QE on a positive charge. On a positive charge, which stops further accumulation. At the static state, at the static state, when or where or when Fe is equal to Fb in magnitude, H Fe is opposite FB. In the static state, FB is equal to FE. This is the force due to battery, and battery force, this is the electrostatic force due to field. It is Q into E. As a charge Q is moved from B to A inside the battery, then work done by battery force W is equal to FB into D, which is FE into D or QE into D. D, the separation between the two plates. D, the separation between the two plates. This work done per unit charge. This amount of work done per unit charge in a positive charge is defined as the EMF of the battery, or E is equal to QE D by Q, that is ED, which is V, the potential difference between the two terminals. Thus, EMF of a battery, thus EMF, electromotive force, of a battery is terminal potential difference V when open, means not connected to any external circuit. If the battery is connected to a conductor, battery is connected through a conductor, then an electric field E, then an electric field E develops from A to B an external circuit. So this inside is the internal circuit, the outside is the external circuit. So if an electric field acts from A to B in external circuit, then what will happen? The free electrons in the conductor will move from, thus a force drives the free electrons in the conductor from B to A. If electrons are driven to this section, then positive potential of this will be reduced. So there is reduction in positive charge of A. Hence, decrease in potential difference. So also electric field. Thereby, electrostatic force is less than battery force. Thereby, electrostatic force is less than battery force. Again, accumulation of positive charge on A and negative on B will continue till a static state where Fe is Fb in magnitude. Thus, potential difference between two terminals is maintained by the battery material, maintained by internal mechanism of the battery material, of the battery material. Often a source is created by two rods or plates dipped into an electrolyte, dipped into an electrolyte, which is known as a cell, known as a cell. This is a battery, or you can write like this: one positive terminal, another negative terminal, the differential terminals between A and B, the EMF, or when they are connected to a resistance where R, between C and D. Suppose I is the current flow. When a resistance where CD is equal to R is connected to the battery, then if I the electric current that flows from higher potential to a lower one, to a lower potential, then according to Ohm's law, Vc minus Vd is equal to IR is equal to V. Again, Va minus Vb is equal to EMF E of the battery. Provided the wire AC, the connecting wires AC and BD have negligible resistance, So you can say that potential difference between CD is equal to potential difference across. Thus, VCD is VAB, or IR is equal to E, or V is equal to E. So potential difference is the terminal potential. So potential difference is difference of terminals potentials when there is flow of current in external circuit that is connected to any electrical appliance circuit that is connected to an electrical appliance. V is equal to E in the case of an ideal battery, and this is the normal way of use of a battery called discharging. another resistance is offered in flow of current from B to A inside the battery as current flows from A to B in external circuit. Work done by the device or battery were done by the device or battery is U1 is equal to EIT, where I is the flow of current in T second. Flow of current in T second. In external circuit, amount of energy developed, energy developed U2 is equal to VQ, that is VIT. The difference of energy U3, the difference of energy U3 is equal to U1 minus U2, that is EIT minus VIT, is used in heating inside the battery material. That depends upon the property of the material and the connecting rods or plates. If small r the internal resistance, then U3 is equal to I square RT. That depends upon current flowing and time of flow and resistance, or I square RT is equal to EIT minus VIT, or E minus V is equal to IR, or V is equal to E minus IR. Thus, potential difference is less than EMF. Thus, V is less than EMF, where current flows from positive to negative in positive terminal to negative in external circuit, in external circuit which is normally used. The reverse way of flow of current, the reverse way of flow of current is known as charging, is known as charging. In that case, V is equal to E plus IR. In that case, V is equal to E plus IR.